Somebody close that door for me, please. Section 1.2, linear measure. Try to keep the notes short so you can get started. What? Stop. I know you can't. It's...
Wait, do you care if we put the assignment on the back of the notes?
No, it's a separate page.
Alright.
Alright guys, I'm trying. I don't know what it's doing, why it's doing that, or what.
Technology.
It's just kind of frozen up. It won't even switch to a different...
Oh. You turned it off.
Dude, I didn't do anything yesterday. I was honestly just like a practice dummy, and I was like, just leave it.
Alright guys, just sit there quiet. We're recording. 1, 2, linear measure. Okay, now, linear measure, exactly that. What is the bottom of this protractor used for? Measuring, correct? So I am measuring the distance from one place to the other. Now, we're going to draw a line. My question to you, kind of a trick question, is can I measure the length of that line?
Yeah, you can't have to move it.
Dude, that line goes on forever. Yeah, that line goes on
The line goes on forever.
You can roll the
Headphones
percent
out, please.
inside the arrows.
Exactly. That's why it was kind of a trick question. And you're not wrong. You're not. If you think, yeah, I can measure that. It's from there to there. But what we're trying to train is in geometry. You got to, we're going to represent things that we can't draw sometimes, like something going on what, forever and ever. Okay. We can't measure this. However, if I put A here and B right here, could I measure the distance from A to B?
That's
Yes. What we call these are line segments. It's a segment of a line. How we write them. If I have AB and I put a segment over it, what's the difference there? There's not what?
arrows.
I am representing the line segment whose endpoints are what? A and what? B. When traveling this direction, this segment stops at what? A. When traveling this direction, segment stops at, and that's why they're called
Endpoints.
endpoints. But if I write this, do you think that means the same thing? It means absolutely. It does mean something that you have to read that and understand what it's saying to you. When I write this, I'm saying segment from A to B. You can say from A to B. It's that segment. When I just write AB, like what have I told you? Mathematicians are lazy. This represents the distance from A to what? I don't have to write out distance from A to B. I want to be able to write AB, and you know that what? I've just, in essence, written down what? Distance from A to B. And that's how you need to read it to yourself. Okay, the distance from A to B is blah, 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 equal to C when you see that, because that's what it is. We just don't want to have to what? Write all that down. But your inner monologue should say, and that's the distance from A to B. Now, and to put it even to more perspective, what am I representing here with this? This picture right here, aren't I? Would you agree with that? What am I representing with this? What is this representing? Think about that for a little bit. What's that representing?
Represents the distance from A to B.
Yes, but what is that represented by?
I don't even read it. A and all. What is that?
Isn't this just a number?
It's variables.
No, it's a number. It represents what? The distance from A to B. If I measure this out, it represents what? We'll be nice and say it represents
2.75.
2 3/4 what? Inches. See the point I'm making? This, put the phone up. Put it up. Represents the distance from A to B, which is represented by a number. This is more, we're representing a picture. We're labeling a picture and saying that segment over there, the one from A to B. I didn't give a, you can't give a number to that. I'm saying that thing. I'm saying just simply how far it is from that point to that point there. It represents a number. Okay? Does that make sense to everyone? Now, I'm going to add something here. I'm going to add another point. You guys, how would you describe C? If you were describing it to me, how would you describe C's location, or what would you say? Okay, you would say C is between A and B. Would you guys agree with that? Well, we have something called the definition of betweenness. And I'm not saying we shouldn't have it, but you'll find that a lot of some of the definitions, theorems, or postulates you have in geometry, some of them are just an official way of saying what's obvious. Things you would not need to know anything. You wouldn't need a geometry class. And in fact, let's say the distance from here to here is 3. And let's say the distance from here to here is 10. What's that distance? Huh?
7.
Everybody look up there and tell me if they're right. Who believes they are correct? Don't worry about drawing it right now, just tell me if they're right. I said, okay, the distance, this represents what? Here to here, right? I'm saying from here to here's 10, here to here's 3. I'm saying, what's that? You guys all agree with them? Did you need to have me as your geometry teacher to know that? Did you have to take geometry? Every one of you probably 5 years ago could have looked at that picture and probably gotten the right answer, would you say? However, in essence, that's the definition of betweenness. Anytime you have these two smaller parts make up the what? The bigger part, don't they? Would everyone agree with that? And that's in essence what this is saying. In other words, C is between A and B if ... How could you guys describe that to me? What do you think I'm saying? I said that the two smaller parts make up what? The whole thing. How could I write that in terms of distance? I don't want you to use a number for A to C. I want you to use something to represent that number. Well, how would I represent the number that represents the distance from here to here? A to C? So A to C, when I what sign or symbol do I use when I want to combine these two? So AC plus, what could I use to represent the distance from C to B? CB. Now when I want to say this and this are the same as something, what do I use? Equals. What does it equal? Not 10. I want you to use A to what? That is the definition of betweenness. The two smaller parts will equal what? The whole thing. So if C is between A and B, then you know AC plus CB is equal to AB. Because isn't it obvious? You got to have those two to make up the whole thing, don't you? However, a simple concept written in, as we could say, a different language. If I said, hey guys, this is what we're going to do today. Get to work. Would you know what in the world I was talking about when I wrote that? You're not going to have a chance. But isn't it kind of funny that that represents a pretty easy thing that you didn't even need geometry to do, right? So that's why it's important, and just as important we learn the language as it is that what? We learn the number part of it, or the adding things together part, so on and so on. This represents a very simple concept, but what it does is it says, I don't have to have numbers in here. I'm saying this distance plus this distance will equal the whole distance. Well, do you guys want to try to write this out as a sentence? The distance from A to C added to the distance from C to B equals the distance from A to B. If you think about it, reading that in a sentence sounds just, if not more complicated than that equation, and much harder to deal with. Okay? So, if I draw another picture here, I'll make it angled. Try to change things up here. Let's make this E. Let's make this F. And let's make this G. And I'll tell you what, let's make this H. Number 1. See if you guys can do this. What do you guys think? Why is this a little harder than what I did up here?
There's more.
There's more. And up here, what did I draw it straight to? The what? Did I use math language to represent the distance from A to C? I really didn't. I just came up here and I labeled it on the picture, didn't I? Which is what we're used to dealing with things like this more, aren't we? The reason this seems so easy is how good of a job as I did of representing what represented each distance, correct? I did the same thing down here, except I didn't put it out there for you, did I? So what should you probably do first? Why do you think I want you to draw the figures? So you can what? Write on those figures. So you can label those figures. So I should probably say E to what? I know there, so that's 4. And then F to G. So that's combining them, so I probably ought to do something like that, right? 10, right? And then what do they want to know? E to G. So they want to know. Now does that seem much easier? Does the language I'm speaking seem... Isn't it just the exact same thing as this up here, except I added a point in between? The two smaller parts equal the whole thing. What's EG equal to? Easy enough? Two smaller parts equal the whole thing. And then see, you can come over here, erase this right quick. You write it nice and right, and then we'll do a second one. How about I see if I can confuse you at all? E to G is equal to 16. HG is equal to 4. EH is equal to 10. Find EF FH and FG. I think I gave you enough information. I got to look at it though. See, even for me, sitting here looking at it when I'm making something off the top of my head, I may have made a problem that we can't solve. So let's label it and let's look. E to G. So that's the distance from here to here, correct? And that's what? 16. H to G. And I'll go ahead and do it like this just to make sure there's no, is 4. Okay. E to H. It doesn't work, does it? I had to have given you a little bit more information, didn't I? Why doesn't it work?
Because 10 plus 4 is 14.
Well, okay, so we'll make this 6.
There you
How
go.
about that? That's obvious, but I'm actually thinking in other terms. Why doesn't it work? Anybody? Do I know the F's in the middle?
Yes.
No. That's another thing, guys. You can't assume. Does that make sense? You can't assume that just because that looks like it might. Well, maybe that's in the middle. You shouldn't just assume that. It has to be told to you. Or you have to have a theorem or something that says that's true. So what happened is, all I know is that if these two added together equal the whole thing. And I know that the whole thing's 10, but I don't know 2 of the parts, so I couldn't find it. However, what if I had added this to it? EF is equal to 4. Does that change things?
Yes, it does.
So, what does that make FH? 6. What does that make FG?
12.
Now we're done. Questions? 2 smaller parts equal the whole thing, right? Here's the fun part. What everybody loves about geometry. Here's your example. Here's your question. Quiet, please. If AB is equal to 2x plus 3. BC is equal to x plus 4. And AC is equal to 19. Find x, AB, and AC. Doesn't that look like fun? No. You guys don't think that sounds like the funnest thing you'll ever do in your life? Kind of hurting me there.
I know it. Got it, Cody.
So simplify all those things.
That is.
Yeah.
Right?
We'll see. All right. How many of you think that looks confusing? I'm with you. It looks kind of confusing in the way it's presented. Confusing's fun because it's fun to figure things out. It's fun to be confused because then you get to figure it out and you feel good about it when you figure it out.
Amen.
See? You didn't think I had an answer for that, did you? Anyway, back to this. Tell me when you see this right here, what popped into your head?
Variable.
Oh gosh, I'm back in algebra. But the word algebra probably popped into your head. Guys, we're going to be quiet. Reinforced it a little bit with this. But the main thing is you saw this and you thought algebra. I got a simple little rule for you we're going to use in geometry. 99, and write this down, 99% of the time, when a problem reminds you of algebra, you need to use the information given to create a valid, and when you think of algebra, what do you think of? Equations? Torture?
Variable.
Probably, but if you paid attention at all, you should probably think of, you learned how to do about everything you could do with an equation, didn't you?
Yes, sir.
Anytime it looks like algebra, 99% of the time, you probably need to create a valid equation. Now, valid is an important word there. These are the problems I'm talking about. You know, there'll be 2 or 3 of these problems on the assignment, and you'll see people that do every single one of their assignments, but they don't do the 2 or 3 that have algebra to do with them. Well, that person's going to make about 60% because a lot of times this is the hardest one and will take the most time. So it's about 10-20% of your workload. But also, I'll see people do this. They'll put gibberish. They'll say, okay, all right, if I see x's, I just make the 2 things equal. They'll say, okay, 2x plus 3 equals x plus 4. They don't even care. Stay off the Chromebook. Okay? You have to create a valid equation. There has to be a reason for making something that leads you to that point. Now, if I look up here, one of the best things you can do is label the what? Picture. It will help. Just so you know, this is the same concept we did just a second ago, just everything's a little uglier. First of all, when I say A to B, whatever's on the other side of that equal sign, what does it represent?
The distance.
Distance from A to B. So what is representing the distance from A to B here?
2x plus 3.
2x plus 3, which is just a number. It's just, I don't know that number. So until I find that number out, I can't, simplify it to an easy number. What about when I say B to C, BC? I'm saying that's whatever's on the other side of that equal sign, no matter what it is, no matter how ugly or how big a number it is, it represents what? The distance from B to C. So what is represented by the distance from B to C?
X plus 4.
No matter what's on the other side of that equal sign, what does it represent? The distance from, which would be here to here, right?
19.
Oh, that was nice. It was what? Something easy, 19. It's just, and everybody has problems with this because it's not a number. Basically, it's just something that represents this. If I said AB was equal to triangle, and I said that the distance from B to C was square, the distance from A to C was circle, can you guys tell me the equation that I could write from that? Triangle plus what? Would equal,
Circle.
why is it any different? Because there's some ugly, kind of expression there. If I said this was 5, I said this was 10, and I said this was 15, what would your equation be? 5 plus 10 equals, does everyone agree there?
Exactly what it is.
So, all I have to do here is what? Use that same concept that I did here, and just instead of triangle or 5, what am I going to put?
X.
Guys, what is represented by the distance from A to B?
2x 3.
So 2x plus 3, because that's what represents the distance from A to B, right? Plus, what is represented by the distance from B to C?
X plus 4.
Is equal to, because the two smaller parts equal the whole thing. What is the whole thing?
19.
Do you see how these three equations, I just use different things to represent A to B, and it's the same template, right? If I'm talking about something up here, shouldn't everybody's eyes be right here? So I need to see your eyes right there when I look around. Any questions on that? Do you see how I got this equation from all of that?
Yes, sir.
It's the same thing we've been doing, just different stuff, right? Just a different thing for A to B. For the rest of this problem, what class am I doing? The rest of this problem is algebra. Do you guys remember in algebra when you had a big ugly equation like that and it looked weird? Do you remember what you probably needed to do to one or the other side of the equation? Simplify. I always taught when I taught algebra, if it looks weird, like what in the world is all that? You can probably write it in a simpler way. I mean, simply, 2x plus x. Is there a simpler way to write that? How about 3 plus 4? I mean, do you say I've got 3 plus $4 in my back pocket, or do you say you have? So you'd say plus what? You guys ever realize that that's why we call it simplifying? Because we want to write it in the simplest terms.
I call it use my brain.
Can you simplify 19? Is there a simpler way to write 19? You don't want to write it as 10 plus 9, do you? You see right it is? 19. Now, does that look a little more like what you're used to solving? Would you guys agree with that?
Yes, sir.
Yeah. So now it's probably when we're going to do what? Manipulate the equation to see what x is equal to. What am I going to do first?
Minus 7.
I would subtract 7 from both sides, because what that leaves me is 3x, just 3x over here equal to what? Now, am I done? Because you don't want to know what 3x's are equal to. You want to know what one of these x's are equal to. How to make any number into 1? Dividing by
3.
itself. I can make anything into 1 by dividing by itself, right? Whatever I do to the left side of the equation, I have to do what?
Right side.
Same thing to the right side. What is 12 divided by 3?
4.
Now, is that my answer?
Yes, sir.
Somebody tell him why. It's not.
Because you got A, B, and AC to find left.
This is the problem a lot of you will make. You'll see a problem like this on a test. I promise you. Hey, listen. Instead of saying find, it'll say what they'll do is they'll make it hard to say find AB. And on the multiple choice test, guess what one of the answers are going to be? 4.
Hey, it's not
They're seeing if you read the problem, right? I personally am not a big fan of that, because in a reading class, it's a math class. If they can get to here, I hate for them to, but that's life. It's what I think doesn't matter. Okay? They might have asked for AB. You do all this work. You do a great job putting the equation together. You find 4 and you forget that they asked for AB, not what x was, right? And you circle 4 and you go on to the next problem. Well, here, luckily, they asked for all 3, so it helps you a little bit. How am I going to find what the distance from A to B is? Anybody tell me?
plug it in.
Well, what is the distance from A to B represented by? 2 times whatever number x is, right? Quiet. Plus 3. I like that you guys are getting involved, but you gotta, I don't want to talk over you. Does that make sense? What is x equal to? What do we find x to be?
4.
Put a 4 right there. 2 times 4 is 8, plus 3 is? This is AC. Now A to C, or not, I should have put BC here, shouldn't I? Next thing we're going to find is BC. So that's a mistake in the problem. Correct that up there. BC is what? Whatever x is, plus what? What is x?
4.
So what is B to C?
8.
Can I check and see if I'm right? What's 11 plus 8?
19.
Probably right, aren't I? Because A to C is supposed to be 19. So as you'll see, these will be pretty easy. But, guys, you skip these problems, I swear you'll get half credit on this assignment. You've got to learn how to do this now. So I'm going to be meaner about this now than I will be in the future. There'll be some pretty hard problems in the future that if you guys don't, you try it or you just get about half of it done, you can't figure it out, I won't take that much off. But this is important. You got to learn to do the easier ones like this now. Okay, spend that time right now so that when it's a little bit harder concept, it makes sense. I mean, for instance, look at number 7 and 8 right there. I've already did it last hour, but they don't even give you a picture, do they? I drew one here, but they don't give you a picture. But if you know B is between C and D, can't you draw that picture if you need it? Isn't that what it's got to look like? And as a result, isn't CD always going to be equal to 2 smaller parts? CB plus BD? And what do they ask you to find? X and BC. So make sure you find those. Over here, you've got some more. Same thing. They say Y is between X and Z. So that means X and Z are on the outside and Y is on the inside, right? And what? XZ is equal to what? XY plus what? YZ, the 2 smaller parts. So all you're doing is plugging the value into this and then solving, aren't you? Finding what they need. Here you'll have to find C and then plug it in to find what? YZ. So on number 21, what would your equation be? What is X to Z, did they say on 21? So 83 is equal to, what is X to Y on 21? Plus, what is Y to Z?
4C.
Okay, what do I probably need to do? Solve for,
C.
and then I'll plug C back in and I'll get what?
YZ.
So I would subtract 11. What do you get? 72 is equal to 4C. Divide both sides by what? C is equal to 18. Is that the answer? No, the answer is whatever 4C is, which 72. So the answer is what? 72. Now, another thing I just want you guys to see, you see that green circle right there? Anytime you see that in the book, not only is the answer in the back of the book, but they've got it worked out for you in the back of the book. So you can see an example of it, all the steps. So anytime you see this green circle in the book, that means, hey, they did that one for me in the back, and the odds, they showed me the steps. Why is that? To help you do 8 and some of these over here too, right? Your pictures. Never in a million years do I want you to, you don't need to draw the pictures for these. Okay? That's the few. However, everything else that isn't a humongous where you have the rulers, you don't need to draw the rulers and the pictures that go with that. You are, for very few times, going to have just a what? Answer there. But of course, I want the pictures drawn and labeled here. I want that question written out, and if you think you just say X is equal to this, you might as well not even done it. What do you think I want to see? The equation, and you solve the equation, just like what I did. Look at it this way, guys. If you know you do it how I did it, like I did right here, erase all my conceptual kind of stuff here. If you did it like that, that's perfect. Do I need the if? No. Do I need the, you know, you get rid of the if. You got to write a little bit to write out the equation or problem here. You don't have to use a straight edge like I did, but that's a really well done problem. But that's the thing. There's only 1, 2, 3, 4, 5, 6, 7, 8 problems like that. One more thing we talk about, and that's this word. Add this to your notes. Congruent. It is okay. Let's say I had a picture drawn. What am I saying with that 10? What am I representing? The distance from A to B and the distance from D to E, correct? Now, is it okay to say this? It is, isn't it? Because this equal sign means the same thing, doesn't it? Is 10 the same thing as 10? It is, isn't it? But you know what you should never say? You should never do that. Anybody want to tell me why? Anybody got a guess?
Because the smaller parts are different?
No? I mean, they're the same size. Okay, let me ask you this. If I ask you, I say, I'm going to pick one thing I want you to copy on my paper, and I said copy AB. Would you get the question right if you copied DE?
No, because you didn't say AD. Right?
But if I say segment AB is the same thing as segment DE, then why wouldn't you be right?
Because you said AD. Because you say
Right, because they're not the same thing. They're the same what? Size, same distance apart, but they're not the same thing. You know, if this was let's say you could physically walk here and I said, hey, meet me at that segment AB, at the middle of segment AB. You'd go right there, wouldn't you? But then you told the next person to meet you at the middle of segment DE. Put the phone up. Now, please. It's not the same place, is it? Okay? It's not the same thing. That's why we have this word called congruent. Congruent means the same shape and size. Now, because this is a line and it has no thickness, shape doesn't matter, does it? They're the same size. But here's the deal. Here's what we use for congruent. We have an equal sign, and we put that over it. So it is correct to say, look, AB is congruent to what? DE. It's on Classroom. You guys know how to get onto it, right?
1, 2. You have a fantastic